NASA just faced a crisis nobody saw coming. Russia's main launch pad is damaged for months, Starliner can't be trusted after stranding astronauts, and Dream Chaser keeps getting delayed. The space station needed a lifeline fast. That's when Musk stepped in with Dragon, costing just $55 million per seat, while competitors charge up to $390 million. How did SpaceX build a spacecraft 7 times cheaper that's now the only thing keeping the ISS running? The situation at the International Space Station turned critical on a single November night. Russia's Launch Pad 31, the only facility capable of launching Soyuz crew vehicles and Progress cargo ships to the ISS, suffered severe damage during the MS-28 launch. Engineers estimate repairs could take 4 months minimum, possibly longer. The technology supporting that pad dates back decades, requiring specialized materials and strict construction protocols that can't be rushed. Winter conditions are making everything worse. What happens when the world's primary space station loses its most reliable supply line? For the first time in 60 years, Russia faces a complete disruption to its orbital launch capability. The Progress MS-33 cargo mission, scheduled for December 20th, was immediately postponed. The next planned Progress launch in March 2026 now hangs in uncertainty. This isn't just inconvenient, it's unprecedented. During the entire space shuttle retirement period, when America had no crew vehicles, Russia kept the ISS operational without missing a beat. Now the tables have turned completely, but Russia's problems are only half the story. When NASA looked at its own options, the picture got even darker. Starliner, Boeing's $4 billion crew vehicle, developed under the same commercial crew program as Dragon, has become more liability than asset. The spacecraft's only crewed mission ended in failure when technical malfunctions prevented it from safely returning astronauts. Those crew members sat stranded aboard the ISS for months beyond their planned mission duration. NASA had no choice but to call SpaceX, asking their competitor to bring Boeing's astronauts home on Dragon. Think about that for a moment. Boeing received more funding than SpaceX for crew development, yet their vehicle couldn't complete its most basic function. How did the company that built the Apollo spacecraft fall this far? The fallout was swift and brutal. NASA slashed Starliner's contract from 6 operational missions down to just 4. The next flight will be crewed, but any missions after that depend entirely on whether Boeing can prove the vehicle actually works. Right now, nobody's holding their breath. Industry insiders are already calling Starliner a cautionary tale about what happens when bureaucracy overtakes innovation. Dream Chaser isn't faring much better. Sierra Space's winged spacecraft was supposed to revolutionize cargo delivery with its ability to land on runways like the space shuttle. Instead, it's been stuck in development hell with delays stacking up year after year. NASA originally contracted 7 missions. That's been cut down to a single demonstration flight scheduled for late 2026. Whether Dream Chaser ever flies operationally depends on that one test. The odds aren't looking great. Even Northrop Grumman's Cygnus, which had maintained a solid track record, took a hit. The NG-22 mission was lost during ground transportation earlier this year, raising questions about quality control. Cygnus returned to flight with NG-23 in September, but confidence took a beating. It'll continue flying, but with a shadow of doubt hanging over every launch. Strip away all the corporate statements and political language, and the reality becomes stark. Dragon is the only spacecraft consistently delivering results. When you need cargo at the ISS, Dragon gets it there. When you need to bring astronauts home safely, Dragon does it. When every other option has failed or faces uncertainty, Dragon remains standing. SpaceX didn't plan to become the sole reliable option, but that's exactly what happened. NASA sees what's coming. The agency is already preparing to ask SpaceX to accelerate Dragon's cargo launch schedule. CRS-34 and CRS-35, originally planned for June and November 2026, will likely move up to May and August. That's only 3 months between missions instead of the usual 5 or 6. A third mission, CRS-36, could fly before year's end. 3 Dragon cargo flights in 12 months represents a massive increase in tempo. Can SpaceX's manufacturing and operations scale up fast enough to meet this demand? The math behind this decision is straightforward. NASA needs continuous resupply of food, water, medical supplies, and equipment. With Russian Progress missions grounded, Starliner unreliable, Dream Chaser unproven, and Cygnus operating under a cloud, Dragon cargo missions become mission critical. There's no backup plan behind the backup plan. Dragon is it. For NASA and Russia alike, this arrangement solves immediate operational problems while avoiding catastrophic supply shortages. The ISS continues functioning, research continues, international partnerships hold steady. But there's another factor driving NASA's decision that goes beyond simple logistics: cost. Musk revealed the numbers publicly when comparing seat prices across different spacecraft. A seat aboard Dragon costs approximately $55 million. Soyuz charges around $80 million per seat. Starliner seats run close to $90 million despite the vehicle's reliability issues. Legacy crew vehicles developed decades ago can cost up to $390 million per seat for certain missions. Dragon isn't just more reliable than its competitors, it's dramatically cheaper, 7 times cheaper than some alternatives. How did SpaceX achieve this when established aerospace giants with unlimited budgets couldn't? The answer lies in SpaceX's fundamental approach to spacecraft design. Dragon was built from day one for reusability and rapid turnaround. The same capsule can fly multiple missions with relatively minimal refurbishment. Manufacturing uses modern techniques and materials rather than legacy processes designed for single-use vehicles. The supply chain is streamlined, the workforce is lean, and the company operates without the overhead burden that weighs down traditional contractors. Most importantly, SpaceX vertically integrates almost everything, eliminating the markup costs that come from layers of subcontractors. Traditional aerospace companies treat each spacecraft like a custom piece of art, hand-built by specialists using carefully controlled processes developed over decades. SpaceX treats Dragon like a production vehicle, building multiple units simultaneously using standardized components and assembly line techniques borrowed from automotive manufacturing. This isn't cutting corners. It's rethinking the entire production philosophy. The cost advantage creates a strategic snowball effect. Lower prices mean NASA can afford more missions. More missions mean more flight experience and data. More data drives faster improvements and higher reliability. Higher reliability leads to more contracts and expanded roles. It's a virtuous cycle that SpaceX's competitors simply can't match because they're locked into expensive legacy systems and organizational structures. Russia understands this calculus too. If Launch Pad 31 repairs drag beyond 6 months, Roscosmos faces a difficult choice: keep cosmonauts grounded and lose their ISS crew rotation schedule, or swallow their pride and purchase a Dragon mission to maintain their presence. Russia will exhaust every option to avoid paying SpaceX, but if the repairs take too long, they'll have no alternative. The geopolitical implications are significant. America's private company becomes Russia's only path to their own space station. For SpaceX, this moment represents more than just additional revenue. Every time Dragon steps in during a crisis, the company's position strengthens. When Starliner failed, Dragon rescued the mission. When supply chains faced disruption, Dragon kept the ISS stocked. When international partnerships hit turbulence, Dragon maintained continuity. This track record doesn't just win contracts, it builds institutional trust that will influence decisions for the next decade. Musk stated last year that the world does not need not reusable rockets and spacecraft that can operate more like aircraft than expendable vehicles. Dragon represents the intermediate step toward that vision, proving that reusability works and showing what becomes possible when you break free from traditional aerospace thinking. But even Musk knows Dragon has limitations. It's a capsule, not a next-generation transport system. That's why SpaceX is building Starship. But until Starship becomes operational for crew missions, Dragon remains the workhorse carrying the entire burden of American and increasingly international spaceflight operations. The spacecraft's importance goes beyond current missions. NASA is planning to use an upgraded Dragon variant to control the ISS's final deorbit sometime in the 2030s. Dragon will be there at the station's end, just as it was there during some of the station's most critical operational years. Beyond the ISS, Dragon's future includes supporting the next generation of commercial space stations. VAST, Axiom Space, and Starlab are all designing their stations with Dragon compatibility in mind. Even Orbital Reef, despite Sierra Space's involvement, may need Dragon support while Dream Chaser matures into a reliable operational vehicle. The commercial space station era will likely begin with Dragon as the primary crew and cargo vehicle simply because nothing else has proven equally capable. There's one more potential role that hasn't been widely discussed: emergency space rescue. When China's Shenzhou 20 collided with space debris, authorities had to prepare and launch a replacement spacecraft on short notice. That kind of rapid response capability doesn't exist uniformly across all space programs. Dragon's reliability, operational flexibility, and SpaceX's high launch cadence make it uniquely suited to serve as an emergency rescue asset. With proper funding and preparation, SpaceX could maintain Dragon spacecraft in ready-to-launch status specifically for emergency scenarios. Response time measured in hours, not weeks. Has anyone else in the industry positioned themselves to offer this capability? The numbers tell a story that's impossible to ignore. Dragon costs $55 million per seat, while competitors charge up to 7 times more for vehicles that can't match its reliability. Russia's launch pad sits damaged for months. Starliner stranded astronauts and lost half its contract. Dream Chaser remains grounded after years of delays. Cygnus is flying under a cloud of doubt. Meanwhile, Dragon just keeps launching, keeps delivering, keeps bringing people home safely. This wasn't supposed to happen. The aerospace giants had unlimited budgets, decades of experience, and government backing. SpaceX was the outsider, the company that traditional contractors dismissed as reckless. Yet, here we stand watching Dragon become the only thing keeping the International Space Station operational. NASA is increasing mission frequency, Russia may have to buy rides from their competitor, and the entire future of low Earth orbit operations now flows through one spacecraft built by a company that didn't exist 20 years ago. The question isn't whether Dragon dominates spaceflight today. That's already settled. The real question is what comes next. When commercial stations launch, when emergencies happen in orbit, when the ISS needs its final controlled descent, Dragon will be there. SpaceX built something the industry claimed was impossible, a spacecraft that's both cheaper and better than everything that came before it. Does Dragon now hold one of the most important positions in spaceflight history? Drop a Dragon emoji in the comments if you agree. Hit that like button, share this video with anyone following the space industry, and subscribe to New Space Review so you don't miss our coverage of SpaceX's next chapter. The revolution in spaceflight isn't coming, it's already here.